Hello everyone, I'm Rishabh Potharla. I'm a student in Atlantic Technological University. I'm completing my master's in blockchain technology and its application, and my roll number is L00186648, and I got supervised by Gary Cullen. This is my dissertation topic. In simple words, can TCP/IP model can be used to mitigate the DOS attack on Avalanche blockchain, and if so, it will actually enhance the network performance and security or not. The main reason why actually I choose this topic is because Avalanche is nowadays becoming popular. I want to see the impact of DOS attack on Avalanche blockchain. For this, for the front end, I have used React.js. For the back end, I used Solidity, and for the attack, I used Web3 and Ether.js, and for the throughput also I used Ether.js. And the key terms that should be memorized is that low fee transaction attack. Low fee transaction attack is nothing but so many transactions are happening with less gas fee, so that the pressure is actually happening on mempool, and mempool is nothing but where the transactions are actually stored, and the latency is nothing but when the transaction initiated, how much time it is taking it to get confirmed. And throughput is nothing but if I send 100 transactions, how much time it is taking to get that 100 transactions to be confirmed. The two limitations that I faced in this dissertation is number one, system capability. To make any attack on network layer and to find the mitigation solution, I need to have a node in my laptop, and it is taking around 500 to 600 GB of memory. My laptop is not supporting, and 16 GB of RAM. My laptop is actually not supporting, and to make any changes without having a node in my laptop, I do not have any authority. So that is the main reason I did not really focus on network layer. So mainly I focused on application layer. And next, we are going to find the implementation of the code. Let's measure the latency and throughput. For that, actually, this is the front end page. I have did it in React. First, I'm going to initiate the throughput. Um, the throughput started, and it takes some time before till that time actually I'm going to find out the latency. I'm going to connect it to my main wallet, and these are all the four different functions. Let's see the latency of each function. For check balance, it is taking 158 milliseconds. This is before the attack. I'm going to send the transaction, make a transaction now. I'm going to send 22 tokens, and for the same account, Control C, Control V. This is the transfer token latency. It's around 6,467. And let's approve the spender now. Let's see the latency for this. And till that time. Yeah. See, for approved spender, it is taking 5,377 milliseconds. Let's find out for transfer from functions latency. For that, I'm going to connect to the account one because I transferred 22, approved to transfer 22 tokens from my main account. So let's find out this functionality, how much it is taking before the attack. It is taking around 5,324 milliseconds. Let's go. We'll compare this values during the attack, how this DApp is actually functioning. Let's find out the throughput. For 100 transactions, it is taking 30.48 seconds. This is before the attack. Now, during the attack, let's find out the functionalities, how this DApp is going to perform. Right now, we are going to initiate the attack. To find out actually the attack is initiated or not, you can see here the method here, everything is transferred. That means that tokens are actually going from one account to another account. But let's make an attack here. I actually return this attack, this low transaction fee DOS attack, in Ether.js. You can see here it is actually failing. The main reason why actually it is failing is because the transaction limit, I mean the gas fee is less. I have actually taking two different accounts. I started this attack from one account, and I'm going to make the attack from another account, so that this is decentralized, so the attacker can use different accounts at the same time, or else he can use bots as well to send low transactions to make this attack. To see the attack is on or not, let's refresh the page. You can see here the transactions are getting failed. That means the attack is on. Right now, actually, let's find the throughput. So the as the attack is on, the effort on mempool will actually starts. And let's find the latency. Now I have started throughput. Let's connect to the main wallet, and let's transfer the tokens. have started approved. I approved account one can send actually 32 transactions from my main account. So let's find out what will be the values now. This I'm doing this is during the attack, and let's disconnect from the account to from main account. I'm going to connect from the account one, and let's make the approve. And these are the values during the attack. Let's find out the throughput. What is the throughput for 100 transaction? It is just taking 30.0.4 seconds. That is lesser than before the attack. So that means the protection is already held. Um, um, as see, you can see here all this transaction got failed because these messages are actually going into the mempool, and there is some operation happening, and mempool actually rejecting it, and these are all actually storing in Avalanche Snow Tracker, where we can track the transactions. Don't you think this is actually taking an energy? Obviously it is taking some energy and the data storage. These transactions are an attack based transactions, and all these attacks are failed for one specific reason, because of low transaction fee attack. So I felt like this is actually a flaw on top of the solution it already exists. It's because why can't we stop this before getting into the mempool? So if someone unknown person is trying to use the D app, and if he sees the transaction history, and most of the transaction histories are like this, and at that time he will get a negative view of the D app. So that's why I found a solution that is actually a blocker. That means I encourage every single D app should use this blocker to stop this attacks. For this, actually, I have made a front end, and for that, actually, I am actually connecting the wallet. I'm actually connecting the wallet from account one, because I'm going to make the attack from account one. See, I have two DOS tokens. I'm going to transfer these two DOS tokens to my main Rishabh account. Control C, and I'm going to transfer these two DOS tokens. So that transaction is successful. I can see the transaction here. It is successful. See, it just now it is fair, it got successful, and right now I'm going to initiate the attack again. That is low transaction fee flooding attack. The attack is started now. Let's wait for some time. See, the account is started. The see You can see the failure message has started. And because I made this solidity code, where the owner of the D app has an ability to block the attack where the transactions are happening. For example, this account is making the attack. The owner admin function, the owner has the power to block this attack, so that the owner this from any transactions from this attack cannot be processed. For that, actually, I kept 100 transaction as a limit, so that if any more than 100 transaction with the same error, that means the owner has the ability to block the account. And let's wait till the 100 transactions happen here. Account one, you can see here all these are failed transactions that we have did it just now. And from the back end, see, I can see here 100 transactions got completed. It failed. So right now the owner has the ability to block the account one. Yeah. Yeah, I'm going to transfer the tokens to the account one. This is the address of account one. You can see here account is x2e2e. I'm going to transfer two tokens. Transfer. I have successfully transferred, and on top of that, I'm going to block the account as well. The main reason I transferred the tokens, because to show from the front end that it cannot make any transactions. See, I have blocked it. See, the account is blocked successfully due to 100 consecutive failed transaction for low gas fee. Okay, and disconnect. I'm going to connect from the and I have the balance is two tokens that I have transferred just now, and I'm going to transfer the same two tokens to my main account. See, it is coming error because it's got failed. Even if I do from the backend, if I want to transfer the token, I'm executing the attack once again from the error. So it is showing an unknown error occurred. So the transactions are not happening now. See, this is 1 second ago I have sent the two tokens, and after that you can see here there is the transactions are not happening. In I can refresh as many times as I can. So, and if I go back to if I disconnect this, and if I unblock the account, if I connect from the main, yeah, if I have as the I have a owner, I can unblock it if it's a genuine account. uh, See, the account is unblocked now, shares, and I can make transactions here now from account one. See, from account one, I have connected, I have two tokens, I can make transactions now. The transaction is successful. And see, I'm not seeing any failed transactions now. I have made one recent transaction. See, it got transferred just 10 seconds ago. Account. Conclusion. By using blocker, the low fee transaction flooding attack can be stopped manually. This can enhance the security of the app in Avalanche and future work. Instead of manual blockers, the smart contract can be implemented to track these type of attacks by using the API of Avalanche Snow Trace. The account can be blocked directly without any owner's concern, so that these kind of attacks can be stopped.